squared. Sometimes it's presented with a little a here, but think of it as the side length squared. So
Okay,
let's
if I was gonna do it with like b
let's do it for 6 just to see that it
for
works.
6, so it would be square root of 3 divided by 4 times 36.
Okay.
Or
36 divided by 4 becomes
9. So then it would also be 9 root 3. So yeah. Cool.
okay. So and I don't know if you would be allowed to use that, but why not? I mean, it's the.
I think we are.
Okay, so let's apply that formula for B, C, and D. Make some room here on the page.
Okay,
So
do you want me to work those out on my own?
Yeah, maybe work out, B and C, and we'll do D together.
Okay.
How are you doing on these? Any questions for me?
Okay, I have the answers for both of them.
Okay.
For B, I got 49 root 3 over 4. I don't think that simplifies out.
Yep, that's good. And for the second one, for C?
16 root 3.
Okay, good. And so for the last one there, the only maybe, uncertainty is like, well, what do you do about this 2 square root 3 when you square it? You square the 2 and you square the square root of 3. So the 2 squared becomes 4. The square root of 3 becomes 3. You're multiplying them. So that's 12. So that's 12. Think of that as 12 over 4 or 3. So it becomes 3 square root 3.
Okay.
All right. So now let's move on to, go back to the chat here, number 5. Look at number 5 next. All right, here we go. Way too many things open. All right, so here is pentagon. All right, the radius of a regular hexagon is, not pentagon, is 12, okay? We want to find the length of one side of the hexagon here. So they're asking for like this right here, S, for example. Now, one of the things you have to do in geometry is sometimes add lines and subtract lines. If I add this line here, that makes a triangle. If I add this line here and this line here, we've got a bunch of triangles. Do you agree with that?
Yes.
There are some very special properties about a hexagon, but I'm going to ask, I guess, do you know any of them? It's okay if you don't. I'm just asking.
Yeah, I know, like, I would generally use, like, if I was trying to figure out the area, I would probably use like the exterior angle theorem and like dividing all the interior angles, like they all add up to a certain number, and like using that method to find the area.
So the sum of the interior angles is n minus 2 times 180, 6 minus 2 times 180, which is 720. But if you want just the interior angle, you take the sum and divide it by the number of sides. 720 divided by 6 is 120. So that refers to like the whole angle here. So if you cut it in half, you get 60. So each of these triangles here, that's kind of what I was trying to get you to tell me, is that each of these triangles is a equilateral triangle.
Yeah. Okay.
And that's the like really, the hexagon's the only one that gets that. You see it on standardized tests. Teachers really like it because it's got a lot of neat properties that you can use. Okay, so the length of one side is the same as the radius. The side here is 12 because all the sides are the same.
Okay.
Does that make sense?
Yes.
All right. Now the apothem is the distance from the center to the side, also known as the height of the triangle. So
Okay.
how did we find the height from earlier? What would you do here to determine that?
So I'd probably drop the altitude and then solve it with a 30, 60,
Yes.
90.
Perfect. Yeah. Can you do that for us, please?
Yes. Okay, I got 6√3.
Perfect. Yes, it's 6√3, and that's the apothem.
Okay.
Now the area of any regular polygon, the area of any regular polygon is 1/2 the apothem times the perimeter. Did you maybe see that in class today?
Yes, I did. Yeah.
So the apothem we have, that's what this is really leading you to. Like if you get the apothem, you can put it in here. The reason you need the length of one side is because if you can find one side, you can get the length of the perimeter. So the way that you might present your answer here is 1/2 6 square root 3. Perimeter is 6 times 12 because there's 6 sides times 12, like that.
Okay.
So we got,
Okay. So once I do that, do you suggest like putting that through calculator, just like doing that? If she wants it exact, just then keep it.
yeah, so the exact means, so the exact here means what you do is you say, okay, there's stuff I like, and then there's stuff I don't like. It's kind of like when you have something on your plate you don't like, you push it off to the side. You don't like the square root of 3, but you do like 1/2 times 6 times 6 times 12. So you can always do that part in the calculator, but not the part you don't like. You just take 1/2 of 6 is 3, 6 times 12 is 72, 3 times 72 is 216. So you could go to a calculator for that part, but this is your exact answer that the back of the book would have, for example.
Okay. Okay, yeah, that makes sense.
Great.
I'm gonna grab my computer charge really quick,
Sure.
just so that doesn't die. I'll be right back. Okay. All right.
Got it?
Yes.
All right. All right, I am a bit uncertain how to proceed on this one. So let me do a quick search of the internet.
Okay, I can also, I think, if I look at my notes from today, it was like something like it was like the I think it just says like if it's inside, then it was like the apothem of a regular polygon is the radius
yes,
of a
that's what I'm.
circle inscribed
Yes,
the polygon.
yes. So the right. So the area of the triangle is 1/2 the apothem, which we have, but
So if
we don't have the perimeter. So there's some relationship between a circle inscribed and a triangle and this. I just need a moment to look this up because
yeah, I don't understand that either. I haven't like seen that. Would we have to like somehow? No, that wouldn't work. Because I was gonna say if we like use the area thing with the side, but we don't have the
Oh,
side.
I'm sorry. Yeah, I'm sorry. The reason I'd look is because I just don't see this stuff very often. So here it is. If you draw this down and this right here, well, that's poorly drawn. This is a certain triangle that we know.
Oh yes, that's right. That's
So
what it is.
it goes back to always having some sort of extra line or drawing something here. All right. So 30 degrees goes here on this angle because it's 60 and you're splitting it in half. So they're giving you the
So
short leg. How do you find the long leg?
so the long leg. So 3 in this case would be the x root 3, right?
No, they're giving you.
Oh
They're
yeah,
get.
yeah, because
They're
it's that way. So it would be the 3 would be the 2x in this case, right? Or is it so the
the
2x is the hypotenuse, so 3
always
is x in
yes
this equation. So it would
yes.
be 3 root 3 for the long leg, right? So
Good.
it would
So that's
be
3 root 3, and then so we double that to get the side. The
so
side
we
is 6 root 3. Good. And then we go back to the area is 1/2 the apothem times the perimeter. So the apothem is 3 and the perimeter is 6 square root of 3 times 3 because you got 3 sides.
okay. So the
That,
area would be 1/2 3 times 6 root 3 times 3.
and I've written this very poorly. It should be 18 square root of 3 like that.
Which is what that is.
Yeah, the 3 multiplies the coefficient, leading coefficient, never the thing under the root.
Okay.
All right,
So
so
then it would just be whatever 3
yeah,
times.
well, I would take 1/2 of 18. That's 9 times the 3 is 27
Yeah.
square root of 3.
So it'd
Like that.
be 27 root 3.
Yes.
Okay. Yeah, I forgot that you can do that.
Yeah, me too. So you're not alone. If you're ever struggling, know that there's a lot of us out here that aren't
Yes.
aren't always on top of this. This is tough. I mean, this is a great book, but it's very difficult for most students. Okay, we'll do 13 next. I believe that's next on your list here. All right, so take a look at this. It says find the one length of one side and one of the apothem of a square whose area is 121. So here's your square. If the area is 121, can you tell me the side?
11.
11 and 11. Yeah. All right. So now the apothem is this distance right here. It's from the center out to the edge.
Okay.
You don't have to overcomplicate it. It's just half the side length in this case.
So the apothem would be half of 11,
Yes.
which is 5.5.
So if you're if you're like, all right, well, I don't even know if that works, you can always check, right? 1/2 the apothem, 5.5 times the perimeter, 4 times 11. And you will find that this does in fact equal
Okay.
121.
Okay, cool.
All right, so the next part here, part B, it says an equilateral triangle whose area is 36 square root 3 square meters. So we've got, and actually, let me go back and look at this previous one. Oh, they don't give you the units of that. That's okay. All right. So the from earlier, we know that the area of the equilateral triangle is square root of 3 over 4 s squared. They're giving you the area this time, 36 square root of 3 equals square root of 3 over 4 times s squared.
Okay.
All right, and then
How
how do you?
would you reverse this? Because this
Yeah,
is
so let's deal with some things I think you might be easiest to deal with. There's a 4 on the right on the bottom, so if you multiply both sides by 4, you see that that would be cleared out. So that's 144 square root of 3 equals square root of 3 s squared. If you have the same thing on each side, you can get rid of that. You can divide it out. So this is
Okay.
144 equals s squared.
So then S would be 12.
S would be 12. So that's thing one. The got to be careful though, right? Like that's this. They want A. So if you think about what we did in an earlier problem, it's this little triangle in here. This is 6. This is 30, 60, 90 again.
Okay.
Okay.
So
You can
would with that, so would 6 be equivalent to whatever x root 3 is?
yes, unfortunately.
Ugh.
Yeah, so you have to set 6 equal to x root 3. Divide both sides by the square root of 3.
Then my teacher likes us to rationalize the denominator.
Yeah. It's necessary. You know, it's the preference. It's a lot of extra work though in some cases. So
So
6
that would
root
come out to 6 root 3 over 3, but then that just simplifies to 2 root 3.
yes,
right?
yes. Yeah, and believe it or not, there's actually rationalizing the denominator and the numerator, which probably didn't want to hear, but there you could actually rationalize this way. This is the numerator. You would never do this, but there are books out there that show this, which is just adds to the chaos of all this. All right, part C.
So what does that just end up being, the apothem, right?
Yep.
Okay. Okay, cool.
All right, a regular hexagon whose perimeter is 24 centimeters. So here's your hexagon. Sometimes it's good to draw it. And the perimeter is 24 centimeters. So that means each side is 4 centimeters. Okay. And from earlier, we know that it's really 6 equilateral triangles.
Yes.
All right, so we found the side length. The side length is 4. The apothem, though, we have to do the same thing again. You have to build this little triangle here. And this time it's 2 there, and you want to find A.
Okay.
So you set
So then that would be 2 root 3.
x root 3, yeah. So you have to divide, or you have to set 2 equal to x root 3, divide both sides by root 3. And like you said so eloquently, you have to rationalize the denominator here. So x is equal to 2/3 the square root of 3, and that is the apothem.
Okay.
Exciting stuff. All right, so I was kind of optimistic they were going to finish this assignment. We still might, but it's like when every problem has 3 problems, it's going to be a little tough here.
That's my teacher for you.
Yeah, it's only 3 problems.
Yeah, more like 10.
Yeah. All right, so let's do these one at a time here. I'll just grab the instructions for the first one here. There is kind of a sequence here. We already did a circle inscribed. Now it's circumscribed about the polygon. So it's a circle of radius 12. So it's good to draw that in. Like what a lot of students do is they'll draw the wrong one. That's wrong. You want to go to a vertex. That's 12. And then you can find some of these other lengths here.
Okay.
So we really want to find, because we want the area of the polygon, we really need the side length of the equilateral triangle. This time you're given the 2x side.
Thank gosh.
Yeah.
Okay, so x equals 6.
X is 6. That's the apothem. If we care, we can do it as a bunch of ways. What's the side length though here? Probably the better, or
The side length of
the triangle. Let's do the triangle first.
So yeah, so that would be 2 times 2 times
you have x.
Root 3. So
yeah, you have x. Just multiply it by the root 3 here.
So it'd just be x root 3 for that one triangle.
But you have the x. What's the final?
So 6 root 3 or
yes.
what?
Yes.
Yeah.
And then for the there's so many. I could maybe understand why there was some hesitation there. This whole length on the bottom is double the 6 root 3, so it's 12 root 3.
Okay, yeah, that's what I was.
Yeah, and that's why I realized what you're trying to say. So we can use that in the formula, the square root of 3 over 4 s squared for the area of a triangle.
Yeah.
Okay, so why don't you do that for us, please?
Okay, I got 108 root 3.
Okay, 144 divided by 4 is 36 times 3. Yes, 108 root 3. Very good. What about these problems seems difficult, if anything, at this point?
It's just like when it's like inscribed and like that one problem that we did with number 10 with like drawing it out that way.
So your teacher's going to give you problems that are like the ones that maybe are more difficult to figure out. So the reason you're doing the homework is that so that you can see what you'll have on the test or the quiz. And hopefully this will start to resonate. Like we're kind of starting fresh now. We're not like catching up, but something to think about here. So it says the radius is 12. And again, like there's a proper radius to draw, and then there's ones that are not helpful at all. So try to, and how do you know? I'm not sure. I mean, you do enough of these, you start to figure it out. If you draw two radii of 24, okay, what is that in terms of this square here?
So
What do we call that in the square?
a diagonal.
Diagonal, good. And this produces a 45, 45, 90 triangle, which you can again find the side lengths from.
So how do I know if it's a 30, 60, 90 versus a 45, 45? Because it's a square, so it would
Yes,
subtract
that's one way. Equilateral triangles, hexagons are 30, 60, 90s.
Okay.
In this case, the two sides being the same mean the two angles are the same. Maybe you heard in class like same sides, same angles, or same angles, same sides for my isosceles triangles.
Mm-hmm.
Maybe, I don't know. Okay. You are given the hypotenuse, so I'd like you to solve this for x, please. And you do have to rationalize here, unfortunately.
So I got x is equal to 12 root 2.
Yes, very good. And that's the side length. That's the S here. It's 12 root 2. Now, sometimes I forget what we're even doing in this problem, but we're finding the area of the polygon. So the area of a square is base times height, or the side squared. You can also find it from the diagonal, but that's kind of a more advanced thing. But it does help on standardized tests, but go for the easy one, right? It's base times height. They're the same.
So that would end up being 144 times 2, right?
Yes, yes.
So that's 288.
Yeah. Now, I don't know if it matters, but in 13B and C, the answers are supposed to have the units, which I
Mm-hmm.
neglected majorly.
No, it's okay. I've been putting them.
Okay, I'm real bad about that because
Okay.
they're not really to scale anyway. All right, part of number C here, 15C. All right. Okay, so again, you got to draw the radius. The radius is 12. There's good radii to draw. That's a good one. This is a good one. This is a hexagon, 1, 2, 3, 4, 5, 6 sides. So, okay, got to find 12, 12, and 12 from that.
Mm-hmm.
All right, so what that does is, again, produces a special triangle. Equilateral triangles turn into 30, 60, 90s.
Okay.
So can you find the altitude of this for us, please?
Okay. So that would be 6 root 3.
Yes. So we didn't need that for the area, but it's nice to do. So the area of the hexagon is 1/2 the apothem times the perimeter. But there's actually another way. You can find the area of one of these triangles and then multiply by 6.
Okay.
But if you like the apothem, you then have to cut then you then have to use this height here, which is probably the direction you're going to go, but you don't have to.
Okay.
There's many ways to do these problems. So perimeter is 12 times 6. You'll notice a lot of these numbers look really, really familiar.
Yeah.
It's like they can't get away from using the same numbers over and over again.
Okay.
So 72 times 3. $16. Does that sound right to you?
Yes.
All right. And I don't see 17, but I can grab it. I've got a copy of this book. If we get to it, we should be able to.
Okay.
So one of the hardest parts about this type of problem, unlike all the others, is there's no picture. You have to draw the picture. So a circle is inscribed in one regular hexagon and circumscribed about another.
Mhm.
All right, so circle is inscribed in one regular and circumscribed about another. So I guess there's 2 hexagons. Yes. Smaller hexagon to larger hexagon. Okay. So might be good. Let me see if I have a hexagon tool here. Draw shape. Where's the hexagon? Okay. All right, no hexagon. Okay, so there's one. This is gonna be the smaller one. So believe, let me draw it in a different color. It might help. Like that. And then there's another hexagon. Like this. This is kind of overwhelming when you draw it. There's so much going on. So what you might consider doing is drawing the 2 of them separately. So I'll try to do that here because I can actually draw a circle that we can draw a nice circle like that. And then I can copy this here. And then we can have the larger and then the smaller here. So the first one is inside here like this. And then the other one is kind of more at an angle, but I think I can do it this way. Boy, that didn't come out very good. Okay, you get the idea, hopefully.
Yes, yes.
Maybe, yes, no, maybe. Okay. So the radius in the first one, that's the 6. The radius in the second one is 6. So notice the main difference is that in the smaller one, it's the side length, and in the larger one, it's the apothem. Does that,
Okay.
yeah. Can I see that? Okay. All right. Now, I think we've actually done these calculations already, but we'll do them again here. For the one in the smaller hexagon here, you and actually maybe I should have drawn it the other way, but you have this triangle here where this is 6, 6, and 6, and you do need the height there. What would that be?
3√3.
3√3. Yeah. So now the area of this hexagon is 1/2 the apothem, 3 square root 3 times 6 times 6.
Okay.
And I know that the traditional course of action here would be to simplify this, but you don't need to. We're going to cancel out some stuff. So we'll do that later.
Okay.
All right. Now the one on the right here, they're giving you the apothem, but you have to find the length, the side length.
That's annoying.
Yeah, sure is. So that's the x√3 side. Could you solve that for x for us, please?
Yes. 2√3.
2√3. So the other one is 2√3. So this one's area is 1/2 the apothem, which is 6. There's 6 side lengths, but they're 4 square root 3 each.
Okay.
All right, and we're looking for the ratio of the smaller to the larger. Okay, so smaller over larger. So that's the 1/2 3√3 6 times 6 over 1/2 6 6 4√3, like that. And because they're all multiplied, if it's the same on the top and the bottom, you can just start canceling. 1/2s cancel.
Okay.
These 2 6s cancel with these 2 6s. This √3 cancels with that √3. And amazingly, it just becomes 3/4.
Okay.
This is one of those problems you see on like a test and you're like, how can that be, how is 3/4 there? Like all the other answers are, more complicated, but it really is just 3/4. So.
Okay.
All right. So, and you're sure it's 17? It's not something from 24 to 26?
Yeah, I just sent, she has like the whole textbook section, but she like has certain problems that she wants to do. So I just like sent all of them
Okay.
over.
All right. Got it. Yeah.
Yeah, it only goes up to 17. But I honestly think that I'll be fine and I should be able to do 17 by myself.
I found it. Sorry about that. I just wasn't looking carefully at my email or my Google Drive here. It came in out of
It's
order.
like on the page with all of that.
Yeah, you're like, hey Matthew, I sent it over, It's late. All right, here we go. Find the area of the shaded region in each polygon. All right. So this is a composite figure. You want to find the area of the square and subtract the area of the triangle. So I'll find the area of the square, 6 times 6, 36, because it's really difficult. And you get the task of finding the area of the triangle here, the equilateral triangle.
And is it showing that all of those sides are equal?
Yes, they are. It is an equilateral triangle.
But the triangle is also equal to the sides of the square as well, or no?
Yes, yes.
Okay,
Yes,
okay.
You can reasonably assume that that's 6 there.
Okay, for the triangle, I got 9√3.
Yep, we did that earlier. So as much as you don't like what's written here, this is the answer. 36 minus 9 square root of 3.
Okay.
There's not much more you can do with this.
Okay.
All right, on to B, part B here. All right, so we got a hexagon. We got a hexagon subtracting out some sort of a triangle. So the triangle appears to be an equilateral triangle. We just got to find its side length, okay? And notice its side length is relative to the apothem. So if you can find the apothem, you can find the side length here. And not drawn, but we've done this a bunch of times tonight. There is 6 equilateral triangles in there. And one of them is 6. Okay. So
Okay.
what would the well, this is 3, this is 3 root 3. You've done this a million times. So the apothem is 3 root 3.
Mhm.
That means your side length of this triangle over here on the right is 6 root 3. So the area of the hexagon is 1/2 the apothem, 3 root 3, times the perimeter, 6 times 6, minus square root of 3 over 4, 6 square root 3 squared.
And does that 6 root 3 come from like using the apothem because it's relative to the base, so it would bisect it, so that's why it would.
It's 2 times the apothem to get the side length, because these are parallel. You're supposed to presume they're parallel. I don't know if that answers your question or not.
Yeah, it does.
Okay. All right, so we've done this a bunch, but I guess these are a little different numbers. 36 divided by 2, so this is 54 square root of 3. On the right here, 108 divided by 4 is 27 square root 3. So these actually do combine to make 27 square root of 3.
Okay.
And see if we got enough time to finish this. All right. So this time, is this the same? Okay, so the nice thing is you don't have to redo the calculation on the hexagon. It's 54 square root of 3.
Okay.
But this one, and we do know this vertical length here. This vertical length here is the 6 square root 3 from the previous problem.
Mm-hmm.
And we do know that this is 6 because it's a side length. So this ends up being actually not that bad. That's actually all there. 18 square root of 3. Mostly because we already did the calculations and
Okay.
problem. All right. Let me know if you need me to scroll up to get anything else, or if you got it all from today's lesson.
Yeah, I got it all. Thank you so much.
Excellent. Here, let me go ahead and stop the recording here, and